Okay, now it's going to be breadth first search, BFS. So now here's example that the nodes will be expanded. The tree, basically the tree which I am going to explain, will be 1 or 2n plus 1 example. For suppose 1, 2 and 2n plus 1 3 and 2 4 and 2n plus 1 5 3 6 7 and so on. Now here's an example that the starting node which I am going to take for breadth first search is start node is equal to 1 and I have to go to let's suppose 13. The search node is 13. So now what will happen if I apply BFS on this tree for solving this problem, which is start node is 1 and search node is 13. So here is just a bunny type example. Bunny type, you can say some rule that for BFS, whenever you try to expand the trees, you can say that put it in a stack. Okay, that is first in first out. So here we see that our first root, the first root node is 1. Okay, so now we'll take this root and put it into the stack. Suppose this is our stack, and now we have put 1 on it. So we will apply searching. So we know that search found equal to false. Obviously we haven't found our search node, that is 13. So now we will go for expansion and we will see that what are the child nodes breadth wise. So 2 is the first and 3 is the first. So what we will do here, we will put these 2 comma 3, these are the other nodes, we will put these into the stack like this. 1, now 2 and now 3. So what is happening here? Now we have to cancel the 1 because it is visited. Now what will happen here, that we will put it we will now search 2 here because it is on the front end of the stack, or you can say the top of this bottom of the stack, so it will go first. Sorry, here is a mistake. Stack is going to be LIFO, last in first out. Here's a clear sorry. Okay, so now 1 has been cancelled. Now go for 2, apply the algorithm. Now as we know, search not found on 2 equal to false. So what will happen here, we will mark it, and but before marking cancelling it, we will take these nodes 4 and 5 and put them in the stack. Now what will happen here, 1 2 1 2. Now 3 will be remain same as it was before, 3, and now what will happen here, 4 and 5 will come in the stack. Okay, now basically what is happening here, you can see that you can assume that these for BFS we are going to take a queue on which we will put the nodes on the you can say the back end. You know, we will put the nodes at the back end and but start taking nodes out from the you can say the first end. Okay, now we will go for 3 and now take 3. As we know, search not found equal to false. Now what will happen here, before marking cancelling 3 as we did to 1 2 3 4 5, we will 3 before marking cancelling we will put these 6 and 7 6 and 7 6 and 7 6 and 7 into the stack, or you can say the queue, and we will put them at the back end. Okay, now what happened, what will happen here, now cancel 3, now go for 4. Okay, go for 4, search not found. As we know, search not found equal to false. Okay, so what will happen here, we will modify our stack and we will do it like this, as we did before. 1 2 3 4, 1 cancel, 2 cancel, 3 cancel, 5 6 and 7 is also in the stack before because of the 3. So we will extend our stack now because 4 is expanded and search is not found. So we will now add its root, its child nodes into the stack. So what are the four child nodes? 8 and 9. So put them into the stack and mark cancel. 8 and 9 here. 4 cancel and 8 and 9. So now, but as the rule says that go for 5 now. Expand 5 now. So 5 is, as we know, search not found equals to true here, because I'm just removing it. 5 not found, true. Okay, now what will happen here, you have to mark cancel it and just put its child node in the stack. Similarly, doing this until the root node is not met, I mean the searching node, that is 13, is not met. You have to keep on searching, and whenever the goal is met, stop searching. So now here, this is the example. This was example. Just you have to do the all step yourself. Now, what is the branching factor? This is an important phenomena. Branching factor. Okay. Now, branching factor is the number of maximum child nodes in a tree that a node have. So here you can see that every node have 2 child. So there is equal branching factor. Or you can say that only every node have a branching factor which is 2. So branching factor is to 2. So the second thing is step cost for searching. This means this is not I think necessary, but the thing is that कि जी अब आप जो है ना, इसको जितनी दफ़ा आपने रूट एक दफ़ा देखें, आप 1 लिया तो कॉस्ट इज इक्वल्स टू 1 हो गई, सही है. फिर आपने किया जी 2 कैंसिल किया, कॉस्ट प्लस 1 हो गई जी. फिर आपने 3 किया, कॉस्ट प्लस 1 हो गई. देन आपने 5 किया, until so you have to keep on adding the step cost. जहाँ से आप जिन दफ़ा आप रूट एक्सपेंड कर रहे हैं उनको ऐड करते जाएंगे +1. ये +1 आई एम एज्यूमिंग स्टेप कॉस्ट जितनी जी हो गई, सपोज इट इज़ गिविंग n step cost n equals to 1 to up to so on. So you have to add these n together. For example, a step cost is 2, so 2 will 2 plus 2 plus 2 plus 2 up to so on. This is the step cost, and the end it will be found. So okay, now here is the depth first search or DFS. So making again the tree, same tree. For example, 1 2 3 and 4 5 6 7 and 8 9 and 10 11 and 13 14 15 11 12 13 2 and for 7 is 14, and then here is 15. So similarly you have to apply the DFS. The same rule will be go for the DFS as we did in the BFS. The difference is as we open the root 1, so the search not found search not found, because we are going for node 13 here. Search not found. Now what will you do? You will expand 1 and put its child nodes 2, 3 now. Okay, now when you will expand 2 here, you will not put its and if the child node is if the search node is not found, you will not put its child nodes at the end of this queue. You will put it before 3. That's the difference. 1. Okay, now 2. Now its child nodes are 4, 5. So you will first put 4, 5. You will give high priority to 4 and 5 as you gave to 3. As the name is suggesting that it is the depth first search. That is the depth first search. That is, you are searching depth wise first, and then going for the first depth, then going the second depth. This is a simple rule. So here it is, 2, 4, 5. Again, when you will search for 4, and if the goal does not met, so 1, 2, 4, and now go for the 4 child nodes 8 and 9. Now put 8 and 9 before 5 and 3. Okay, now here we see that now the 8 and 9 don't have a child node, so obviously search will be failed on these nodes, so we will cancel. See, we are going to cancel here. So 1, 2, 4, 8, 9 are visited and the goal is not found. Okay, now what will happen here? You will go for 5 first, and when you will go for 5 first, I can write it here: 5, 10, 11, and then 3, which is at the end of the queue still, because we haven't finished our first depth. So again, 10 and 11 will reply negative boolean. So 5, 10, 11 will mark cancel. Now you will go for 3. 3 we know does not meet the goal, so you will expand its child nodes, which are 6 and 7. You will cancel mark 6, mark 3 as cancel. Now what will happen here? As you are going to expand 6, you are going to put these 12 and 13 before 7. Okay, now 3, 6. Okay, now 12, 13, and now it's going to be 7. So 6, 3, 6 cancel, mark cancel. Now it's turned to 12 and 13. So there is a difference between the BFS and DFS. That the BFS, whenever the goal is met, the search is stopped. But in DFS, you have to, for example, you have to carry on the search. For if elements carry on the elements which are in the queue. So here it is 13. As we know, the goal is met after visiting 12, because we have it is first in the queue. So we have to visit 12 before 13. So after 12, when we visit 13, so the goal is met. So what will happen here? That it will it will mark 7 as visited and check its child nodes. That is, child nodes are 14, 15. This is the difference. And now after visiting it will return 0 negative boolean. So what will happen here? 13 will be met, but you have to write the step cost until you have found 13. That is, you will not count the 7 and you will not count the 14 and 15. The other, after the simple rule, after 13 you will not count the step costs, but you will perform the action as it is required in depth first search. But you will only count step cost until your goal is met. That is the difference.